So here are different choices for inequalities. We can have what we would call a greater than sign. And what that means is whatever's, I think I mentioned this in an earlier video, think of it a inequality sign kind of like it's a triangle, and the larger side of the triangle is where the greater stuff is, the bigger number is, and then the small little point of the triangle is where the little number is. So I'm going to take that off. This would be a greater than sign. So a true greater than statement would be 5 is greater than 1. So there's an example. We can also have less than sign. So here's an example. -3 is less than -1. Sometimes that can throw people off because it seems like, wait, why is 3 smaller than 1? Well, -3 is more negative than -1, or on a number line, the -3 is down here. The -1 is up here, so this is less than -1. The other two types of signs are greater than or equal to, which looks like this, or less than or equal to. And that makes more sense in terms of using a variable. So we'll do that in just a second. But this is, just for definition's sake again, this is the greater than sign, the less than sign, the greater than or equal to, and the less than or equal to. So let's look at a statement like this. We'll say x is greater than or equal to 3. So it almost looks like an equation, except for the fact that it's missing the equal sign. So that's why we call this an inequality. So x is greater than or equal to 3 is an inequality. And one of the things we like to do with inequalities very frequently is we like to give a visual for them, or we call it graphing. Now usually when you think of graphing, you think of like a horizontal line and a vertical line. We have an x and we have a y. Not that type of graphing. We're talking about one-dimensional graphing. So we have a line. I'll mark off our 0. And then I'm just going to put 1, 2, 3, 4, 5. I think that's what I'll do as. And then I'll do -5. 1, 2, 3, 4, 5. This is -5. The way that I graph an inequality like this, x is greater than or equal to 3, is first of all, I find my boundary, which is 3. So that's right here. I'm going to make a nice little dot that I've filled in. And this statement is telling me that x, this quantity x, the x is always like a mystery quantity. We don't know. It's kind of like, what is it? Like, ask me 20 questions. We don't know exactly what number it is, but we're given the hint that it is greater than or equal to 3. So where could x be? Well, it can't be any of these numbers that are less than 3. But on the other hand, it could be any of the numbers to the right, any of the numbers that are greater than 3. So we're going to draw a little arrow that shows that x could be 3 or anything greater than it. You often will see in your textbooks, like, they'll double shade here and make a nice little graph that shows that 3 or x can be 3 or anything greater. I find that just gets messy on your page doing that much scribbling. So I tend to make a dot and then kind of make an up and over arrow, or if it was a less than, I would say up and down. So that's my recommendation. You can do it however you like, but that's how I'll use it. I'll draw it in my examples. Let me give you another example. Very similar, but let's say x is just greater than 3. How's that different if I try to graph that inequality? Well, note that the only thing that I've changed is the inequality symbol itself. It's no longer equal to 3, but it could be anything greater than 3. Now I'm actually, well, I guess for good measure, I'll put in the negatives. We're not really talking about the negatives just yet. But where is my value 3? Right here. Now I'm going to create what we call an open dot, I'm not going to fill it in. Now stop and think, make a guess. If I was in class, I'd ask you what you think your guess is, but you'll have to think about it in your head. Why do you think that I'm not filling this dot in? Up here I had a nice filled in solid dot. Here we have what we call an open dot. Well, the reason that I'm doing that is because in my statement, x is greater than 3, I have not put an equal sign. That means I have not included 3 in my values of x. So 3 is not a possible value, so I make it open, but anything greater than it could work. So I still put my arrow just the same. The only thing that has changed is the open dot versus the solid dot. Now, just as one more example that, well, I'll do this. Just what x is less than -2. How would I graph that? Very similarly, I'd create my line. 1, 2. You don't have to draw out all of the hash marks every single time, as long as you scale it appropriately. So make sure that you, like if right now I'm trying to locate the number -2, I'm going to put it here. I wouldn't put it up here, right? So if you want to draw simpler, I'll draw it up here in the corner to show you what I mean. If you want to draw something simple and just say 0, and here's -2, I'm okay with that, as long as you don't put -2 up in the positive zone, because then I'll mark you wrong. But it's okay, you don't have to draw out super detailed graphs. I'm not into having you waste time just to draw a pretty picture. I want to make sure you understand the math. So where's my boundary? -2, it's right here. I ask myself the question, is this a closed dot or an open dot? Well, it should be an open dot because we're talking about less than, not less than or equal to. And which directions should the arrow point? Where are the numbers that are less than -2? Well, they are to the left, anything below -2. So up at the top here, we have a graph for x is greater than or equal to 3. My second graph is for x is greater than 3, but not equal to. And then my final graph here is for x is less than -2. All right, let's take a quick break, and then we'll come back and look at how inequalities can be solved in the same way that we solved equations.